So a small brief of vectors, and then we will go to the forces part.
Okay.
I'll just tell you a small application, like we have done projectile also. Okay, in
Yeah.
projectile we saw the components of velocity, u cos and u sine. Okay, similar to that, whenever there is any vector, like if there is any vector which is inclined at an angle, okay, this angle can be in any orientation. So I will make few different orientations so that you should be able to develop your thought process based on that. Okay, these are the vectors in different orientation. Okay, because in actual question of physics it is not necessary that you will be getting only horizontal lines. There can be any of the lines. So we have done this. Now we can take one of this. Okay, so these many orientations are fine to develop your thought process. Okay,
Okay.
now in general for a vector we have discussed that the components of a vector are what. Like if it is A, then this will be A cos theta and this will be A sin theta. Like this is the basic.
Yeah.
Okay. Usually we do it like that horizontal component is A cos theta and vertical component is A sin theta.
Yeah.
But as soon as we are into the system where the lines are tilted, like particularly number 2, number 3, and number 4. First three
Yeah.
quite sorted, it's a horizontal line, so we can very easily think of. But what
Yeah.
do we do for second, third, and fourth case? So then for taking the components, we have to always remember one thing, that the component in the direction of angle, like I'm talking about which components, I'll mark for all of them. These are the components in the direction of angle.
Okay.
Okay, I hope you
Okay.
are clear. There is no
Yeah.
vertical horizontal from now on. There are two components. One is in the direction of angle and the other one is perpendicular to that. So the other one literally you don't have to remember, because if you understand all these green ones, the other one
Yeah.
by default clear to you that what it will be. Okay, we always have a confusion that whether we should take A cos theta or A sin theta.
Yeah. Yeah.
Okay, so that
Yeah.
thing exactly we are discussing over here. So for the first one, in the direction of angle, it will always be A cos theta. Make a note of it.
Because that's horizontal. Yeah. The
Yeah,
thing.
but
Yeah.
horizontal is applicable only for first case. For case
Yeah.
2, 3, and 4, you will not be able to see
Yeah. No.
horizontal.
Yeah.
Okay, so
Yeah.
this causes confusion.
Yeah.
Okay. So what we are doing, we are changing a small part in the concept, and instead of saying horizontal vertical, now we are saying what? The component in the direction of the angle. It is the same thing. Where is the
Yeah.
angle? Angle is here. So in the direction of angle, what is the component? A cos. It will
Equals
always
theta.
be applied for all the system. So this will be A cos, this green one will be A cos, and this green one will be A cos,
Okay.
irrespective of how they look, because appearance is like it is deceptive. Okay, you may get different appearances, but this thing will be common. They all are in the direction of angle. Is that clear?
Yeah. Yes, sir.
The other component is a perpendicular one, like it is perpendicular to the previous, like A cos theta and A sin theta are always perpendicular to each other.
Mm.
So this will be A sin theta. This will be A sin theta. Here in case number 3, this will be A sin theta. And in case number 4, this will be A sin theta.
Okay, yes, sir. Just
Okay.
yeah, I'm just drawing it.
Now to make your understanding more proper, what I'll do, one diagram at a time. Okay. Once you're done
Okay.
with the first, let me know. Okay. You will find all of them all together on different slides. Okay. But then there will be no confusion.
Okay.
One is done.
Yeah.
Okay. Now the second diagram. This was the first one. No? Draw the second diagram now.
Yes, sir.
Second is done. Is it clear?
Yeah. Yeah.
Then third one.
Just done.
Done.
Yeah.
And the fourth one now.
So done.
Okay. Now
Yeah.
on this slide, you will get all four of them together. Okay.
Yeah. Okay.
I'll pass it on this after the lecture, so you can just go through it once again. But the
Okay.
point,
Thanks.
now onwards, you don't have to think of any horizontal or vertical. Okay. Always go with in the direction
Yeah.
of or the other one.
Particular. Yeah.
Okay. Now let us see one inclined plane, and on the inclined plane, like how do we see the angles? Let us see it. This one. This is theta. Okay. A block is kept over here like this, mass m. We need to make all the forces which are exerting on this block, okay, or which are there in this system.
Okay.
Okay, that is basically called as free body diagram. Have they used this word in school?
Yeah.
Free body diagram is a diagram in which we represent all forces. So you can just watch it. The first force for the block M acts vertically downwards, which is basically mg. Mg can also be written as W, so you will find it
Yeah.
W also written somewhere. Okay, so let's write W only. W is the weight of the block. Okay,
Yeah.
weight always acts vertically downwards. So whether you are standing on a horizontal ground or on an inclined plane, it doesn't matter. It will be vertical only. Okay,
Okay. Yeah.
but if I talk about the reaction force of this green plank on the block, so that reaction force will always be perpendicular to the surface.
Yeah.
If you
Okay.
look at this surface, this is the surface, okay? So the reaction force will be perpendicular to that surface. Because of that, it will be drawn like this, R. R is called as the reaction force,
Okay.
okay? Now, this W, since it is acting at a certain angle, so it will have two components. One of the component will be,
So the one going down would be mg mg cos theta, right?
this one,
That would be mg sine.
this one which I am drawing now, this is what?
Wouldn't
This,
that be mg sine theta?
okay. Before you
So
guess,
because you said it's perpendicular, right?
before you guess anything, let me just write it down first. Okay. You have to understand where is the theta. Okay. Don't try to learn it. Till now, I think you have learned this thing that one will be mg cos and other will be mg sine.
Yeah.
You should be able to see it on this. Okay. So if this is angle theta, this will also be angle theta. How? Let me show you over here. I'm saying that if this is theta, this will also be theta. It is a simple mathematics applied over here, basic.
Yeah.
Okay. So what I'll be doing, this is 90 degree because I have drawn a perpendicular line. This will be 90 minus theta. This is 90 minus theta. Overall, this is perpendicular. So if this is 90 minus theta, the other one will be theta only. Then only they will become
Oh
90.
yeah. Yeah.
So because of that, now onwards, like this whole story, you need not do it all the time. Now onwards, you can remember that this angle will be theta. Okay. Look at the cursor, this angle. Okay. Is it clear?
Okay. Yeah.
Now, keeping everything aside, you tell me, just now only we did all those cases. Okay. So in that, what we did, the
That
component
the
in the direction of angle is cos theta. Do you remember?
yeah.
So which one should be
Oh,
cos theta?
so the one going down would be cos theta.
Yes. Do you need to learn this?
No.
Definitely not. Okay, never try to learn it because next time I will change the angle and you will be all wrong. Okay,
Yeah.
means this will happen in exam. Exactly the same thing happens in exam. Okay, just imagine if someone gives you an angle over here. Let's say this is alpha. You have
Yeah.
learned the going down is mg cos. You will write it down as mg cos alpha. It is wrong. Are you getting my point? If angle
Yeah.
change, the whole perspective will be different, and if you follow the same logic, you will be incorrect. Okay?
Okay.
Understand the concept. What was the
Yeah.
concept? That the component in the direction of angle is cos theta. Simple.
Yeah.
Okay. So the other one will be mg sin theta.
Yeah.
Both the gray components are clear.
Yeah.
Okay, now when we have made the components, we don't have to even use mg because the effect of mg is there in mg cos and mg sin. So in our actual calculations, we are not going to use mg anymore. Okay, we will be using its components only. Is that clear?
Yeah.
Next, there is one more force which is acting on the block. Let's say this block is not moving down right now. Okay, it is there only, it is still. Because of the friction only, it is still over there.
Yeah.
Okay, but there will always be a tendency of this block to move down. Yes or no?
Yes.
What is the meaning of this tendency? So for that, you have to do one experiment in your home. Okay, uh, just go to the tea table or any small table. Okay, and keep some object, like you can keep a computer mouse or a bowl, anything. Okay, bowl, if you're keeping it, shouldn't be a glass bowl. Okay, and then try to
Yeah.
tilt table from one side.
Sorry?
Try to tilt table from one side. Okay, so the
Okay.
whole system will become inclined like this. Like
Yeah.
initially, if the table is like this, okay, and now you are trying to tilt it, so what will happen? The whole system will become inclined. If you are tilting the table like this, it will become inclined.
Yeah.
Can you see that?
Yeah.
Okay. Now the thing is, when you are actually doing it now, so up to a certain level, this is a block or this is the object which is kept on that. Up to a certain level, this block will not move. Okay. Up to a certain
Yeah.
level, this block will not move. But after that, the block will start moving downwards.
Yeah. I'm doing it right now. Yeah.
Okay. Are you getting that point?
Yeah. Yeah.
So if it starts moving downward, it means now the body is sliding down, okay? And the friction which will act on that body will be a dynamic friction because the body,
Yeah. Yeah.
okay, dynamic friction. What is dynamic friction? It acts on a moving body. A car is moving, any body is moving, you are walking. So when any body is moving and it is coming in contact with another body, there will be a friction for sure. So it will
Okay.
be applicable in moving bodies. And the previous case where it was not moving, you were tilting it to a certain angle, but it was not moving. So since it was not moving, so the friction which was
Static.
there, that is called as static friction.
Okay.
Okay, so static means rest. So when a body is at rest, the friction will be static friction. Okay, coming back to our example, this block, though it is not moving, but it will always have a tendency to move in which direction?
Downwards.
Okay, now do you know that why I told you the whole story?
Yeah.
The reason, just to make you understand that if a body has a tendency to move in downward direction, the force of friction will always act opposite to that.
Okay. So force the
Darker
friction.
color. So the force of friction will always act opposite to the direction of motion. When I say opposite to the direction of motion, you will have a question that the body is not moving, then how can you say direction of motion? So in that case, we also consider the tendency, like a body is having a tendency to move downwards. So friction should act in which direction? Upwards. This
Yeah.
friction is the only force which is holding this block to move up to a certain angle. After a certain angle, this friction will say, now I'm done, I can't help you out. Okay. So this body will move down. Okay. But up to a certain angle, friction will hold this body at the same position, it will not move.
Yeah. Okay.
Okay. So all the forces which can be applied, we have listed over here. Okay. And the last
Yeah.
what we have to do is like, how do we solve a question? So in a question,
Yeah.
we usually do force balancing. Okay. Assuming that the whole system is at rest. I will discuss two cases. This is a case where we are talking about the whole system is at rest. Rest means the block is not moving. Okay.
Yeah.
So
Okay.
the net horizontal force and net vertical force, they will be equal to each other. Like the net vertical force, what all forces you can see vertically?
The reaction force and the oh, that
These
is
are the
why.
vertical force. Okay, because now you have to assume the whole tilt and vertical and horizontal will be as per that tilted angle. Okay. So this is like that vertical force. So I will write
So
R.
even mg cos theta is a vertical force.
Yes. For this case, it will be like a vertical force. It is not
Okay.
exactly vertical, but if you are considering the tilt, let's say if you are standing on this hill, so then you are definitely going to see R and mg cos theta as vertically upward and downward.
Okay. Oh, so they have to be equal to each other.
Yeah. This is the case
Okay.
of force balancing. This is how we solve a question.
Okay.
Okay, so if a body is at rest, it is not moving. Why it is not moving? Because forces, the net forces on it are equal. This is one of the equation. The other equation will be F is equal to mg sine theta. This is the friction force.
Okay.
Oh,
Yeah. Okay.
clear? Now force
Yeah.
of friction is usually written as mu r. Okay, what is this mu? We will discuss a bit about this as well, and then we'll move on to our next case. Force of friction is written as mu r, where mu is called as coefficient of friction, okay, and r is the reaction force applied by the surface. Okay, this R was the
Mm.
reaction force which was applied by the wedge, by the inclined plane. So R is the reaction force applied by the surface.
Okay.
Okay, now there are few properties of mu, okay, which you should know. First thing is this mu will always be, this mu will always be between 0 to 1.
Okay.
Okay, it can
So
never go beyond 1, it can never go beneath 0. Okay, it can't be negative. If you're getting a negative value, then it's not
something's wrong. Yeah.
okay, and it cannot go beyond 1. So it will be between 0 to 1. Okay, then we discussed that there are two types of friction. So mu of static friction and mu of kinetic. Some people call it as kinetic friction, or it is also known as dynamic friction. So I'm just introducing a word kinetic. Kinetic means movement, motion.
Okay. Yeah.
Now you just use your general understanding and tell me that in which case there will be more friction, when a body is at rest or when a body is moving.
When uh when the body's moving,
Okay, I'm more interested in the reason. So can you tell me the reason?
surface both the surfaces are sliding against each other. So but then also like when it's at rest, it's friction that's holding it together at rest, yeah.
So which
I
portion?
don't know, I'm confused now. Um
Okay, let's take one real life example. Okay, just imagine that now your winter vacations have been started. Okay,
yeah,
20 days, 30 days vacation. Okay, you have to imagine, that's why I'm saying so many days. In reality, it will never be. Okay, so 30 days vacations have been started from today. Okay, and today you have taken a pledge that I will get up early every morning and I will go for jog. Okay, I can understand it is too much painful to wake up early in the morning, especially when you don't have school. Okay,
yeah,
but you have taken a pledge. Okay, so you tell me that initially, will it be easier for you to wake up early? Like, let's say, initial 7 days, we are doing it like a drill, a trial drill. Okay, but somehow by hook or by crook, you have to wake up for 7 days at 6 a.m. Okay, so for those
yeah,
7 days, will it be easier for you to wake up or it will be too much difficult?
it'll be difficult.
It will be difficult for sure. Okay, but if you did that for 7 days, then don't you think that eighth day will be like, oh, I'm used through of it now and I can very easily wake up and go. Will you be having
Yeah,
that attitude or still you'll be having the same attitude of day one?
the first one.
The first one, okay, you will be like easy now that yeah, it is fine. I go every day, so it is not a big deal. I can wake up again tomorrow. Okay, your
Yeah,
attitude will be like this. Okay, so the point is, as we start something, the big resistance is always there in the beginning.
okay,
Resistance means from our within we are getting a no. No, I don't want to wake up. No, I don't want to go out. I'm okay. I'm not that fat. It's fine. Okay. Don't want to wake up and go, and I don't want to disturb my sleep. These are all the statements which your devil mind will be saying to you. Okay.
yeah,
I have to wake up. So those are all internal resistance. So that resistance will be quite high in the beginning, but as you will start waking up every day, you will start going out every day, then you will be like, okay, it is not a big deal to wake up early. Are you understanding?
yeah,
So the same thing happens in friction. When a body is at rest, it is very difficult for a body to start and come into motion. Because of whom? Because of the static friction. This static friction is acting as a evil. It is not letting
okay,
the body move. But as soon as the body starts moving, then it is not difficult for the body to keep on moving. Okay.
yeah, makes sense.
You can correlate this with the example of waking up
Yeah,
and going. Okay. So this is exactly the same thing happens in friction. Because of that, now you will remember the whole story and you will always remember that static friction is always greater than kinetic, because
okay,
it is always difficult in the beginning. Once you start moving, it's fine. You will grow, you will prosper. But until and unless you start, You will be having lots of questions, you will be procrastinating, you will be doing all those things. Okay, so that is all part of static friction.
Yes, sir.
Okay, so is this thing clear?
Yeah.
Okay, anything you want to write from here?
Sir, I've written it all down, sir.
Okay, so coming back to our example, this was a case of rest. Okay, so we have just written R is equal to mg cos theta and F frictional force is equal to mg sin theta. Okay, that's it. When it
Okay.
is about solving a question, then there will be something over here which will be unknown, which we have to find using these equations. Okay, it can be anything.
Okay.
So you should be able to just write these equations, and if you learn to write, then yeah, it is very easy later on.
R equals to H plus theta.
So any other question you have over here?
No, sir.
Oh,
Wait, but sir, you said that if the angle changes, like if theta changes, and it's not, but will it always be those forces? No, right? Because you said if the angles can change.
yes.
So then,
Okay, if angle will change, okay, like if the positioning of angle is changing, okay,
yeah,
let us discuss one more part of this. Instead of theta, we are writing our components in the form of alpha. Okay, now where is alpha? Let me draw here. Okay, I'm drawing with a glitter pen. I hope you can see that.
yeah.
Okay. Now, with respect to that, you just try to recall the initial concept we discussed in today's lecture. That how do we write the component? In the direction of angle, it will be cos, and
Theta.
the other one will
Yeah,
be sine. Okay.
yeah,
So now I will cancel them, both of them. Intentionally, I am keeping it so that you can understand them comparatively. So in the direction of alpha, this will be mg cos alpha, and the other one will be mg sin alpha.
yeah,
Okay, and
yeah.
and the best part is mathematically they are still same, though they look different, but they are same because sine and cos are complementary angles. Now
Huh?
what is this? Okay, I'll tell you with the help of an example. Okay, example means I'll use the numbers so it will become more clear
So
to you.
wait, is this trig? Am I doing trig right now? Like,
Take
because but like trigonometry, because like if it's like a right angle triangle, yeah, and then they've given you the sides, and then they ask you to find for the same theta, both sine and cos,
uh,
um, aren't they like similar? I don't know.
no, they will not be. We'll be discussing one real life, like we'll be taking a value of theta basically. Okay, so
Okay.
by contrasting values, you'll understand this thing. Okay, let's say the value of theta is 60 degree. Okay, you keep your calculator handy. So
So
if
wait,
uh,
it's okay.
go on.
Yeah.
If theta is 60 degree, then alpha will be 30 degree. Do you understand with the help of this diagram?
Sorry, can you tell me again if theta will be?
Theta is 60 degree, then alpha will be 30 degree.
Yeah. Yeah.
This is clear enough. Now I will
Yeah.
just write down the equation in terms of theta. What were the equation? R is equal to mg cos theta, F is equal to mg sin theta. Okay.
Yeah.
So R is equal to mg cos theta and F is equal to mg sin theta. If I just put the values, okay, you just put the value of cos 30, sorry, cos 60.
Okay.
Cos 60 is 1 by 2. Okay, so you will get it as mg by 2. Are you getting 1 by 2 as the value of
Yeah,
cos?
1/2. Yeah.
So the value of r is mg by 2. We have to just keep it like this because we are comparing the two cases. The other one
Okay.
is, if you put the value of theta as 60 degree, sine 60 is root 3 over 2. So I'll be writing it down as mg root 3 or root
Okay. Yeah.
3 by 2. Is that clear?
Yeah.
Okay, now come to alpha. In alpha, what were the components? The components were just opposite. So if I have
Yeah.
the equation R is equal to mg sine alpha, is that what I will be writing?
Yeah.
Okay, I'll write over here. R is equal to mg sine alpha and F will be equal to mg cos alpha. Okay, look in the diagram. F is equal to mg cos alpha. Is that clear?
Yes, sir.
Now, if I put the value of alpha as 30 degree, sine 30 is 1 by 2. Check it in the calculator.
Yeah.
So R will be mg by 2 and cos 30 is root 3 by 2. You can check the same.
Okay.
So it will be mg root 3 by 2. Now compare the values. Both of them are
Yeah. Same.
different
Like
perspectives, but
value.
they have same answers because they are
Yeah.
actually same force. Force is not changing, but the way we are writing is changing.
Makes sense. Yeah.
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 So once again, I'm saying that if you want to be happy and clear with the concept, if you don't want to be confused, then always remember this thing that the component in the direction of angle will be cos. You change the angle, I will write the component. That should be the attitude. Okay. I changed the angle, I made it alpha over here, then component accordingly changed, but the value still remains the same because it cannot change. No? The value of force will remain the same. It cannot
Yeah.
be sine and cos. Sine and cos are just instruments with the help of which we are getting the answers. Okay,
Yeah. Yeah.
so the proof is over here. By taking values, we can see that we are finally getting the same answers for R and F. Okay, and this was for rest when the body is at rest. Okay, any doubt you have till here?
No, sir.
Coming to the next case when body is in motion. Now in motion there are two cases. First is that let's say now you have tilted the table to such a level that the object starts dragging down, sliding down. Okay, but that sliding is happening with a constant velocity. All right, though it is a motion, but it is a constant speed or constant velocity. Okay, now if it is a constant speed, can you tell me that acceleration will be zero or non-zero? What it will be?
Acceleration will be 0.
You are clear with that? If it is a
Yeah.
constant speed, acceleration will be zero. If
Yeah.
acceleration is zero, it means it means I'll just write like this so that you can understand. The body is moving in this direction with a constant velocity. Okay. So the downward force is mg sine theta minus the upward force. It is always taken like this. The downward force minus upward force, this is the net force acting on the body in which direction? In that horizontal direction.
Yeah.
Okay. And that will be equal to mass into acceleration. Newton's second law says net force is equal to mass into acceleration. Okay. So we are just using Newton's second law over here.
Wait, sir, could you say that again? It's kind of zoomed out, please.
mg sine theta minus F is the net force acting in the horizontal direction.
So mg sine theta. Oh, that minus the force of friction is
Yes.
the. So we're calculating the resultant force. Yeah, like in that direction, essentially.
Yeah.
Okay.
Resultant force is mg sine theta minus F.
Okay. Okay.
Okay. So
Yeah.
this resultant force mg sine theta minus F is equal to mass into acceleration. Now, as I said that this body is moving with a constant speed, so acceleration will be zero. So this whole term will become zero. Okay. If this whole
Yeah.
term will become zero, I'm just showing you how to calculate. Like by doing all these things, we are actually solving n number of numericals. In the numericals, these type of things will be there and you have to just solve using the same steps. Okay. But still, once you are clear with the concept, we will be doing some numericals as well. Okay. So that will eventually give me mg sine theta is equal to f.
Okay. Yeah.
Is this clear?
Yeah.
And what about r and mg cos theta? Will there be any change?
No.
It will be same. There will be no change. So r will be equal to mg cos theta.
Yeah.
Okay.
Oh, okay, that makes more sense. Okay. Yeah.
Okay. So
Yes.
constant velocity or constant speed, zero acceleration case is same as when the body was at rest. Okay, it is same. But when there will be an acceleration in the body, like now we are going to take the last case of motion, and in this motion we are taking an acceleration. Okay, acceleration means body started in a subtle way, but now it is moving faster. Okay, so the body is moving down with an acceleration of a. Okay, we're going to write the equation in the same format. Mg sine theta minus f is the net force in the horizontal direction. That will be
Yes.
equal to mass times acceleration.
Yeah. So
Okay.
acceleration in this case, are we considering acceleration as like not zero?
Yeah,
Is it
non-zero.
constant?
Non-zero.
Okay.
Okay, it is a constant acceleration, but it is a non-zero acceleration.
Yeah, yeah, yeah.
Okay, so that will give me mg sine theta minus f is equal to ma, and another equation will be r is equal to mg cos theta. Okay,
Yeah.
I will be solving it from here and I will tell you the value of acceleration. This is one of the MCQ which is usually asked. Okay, so we have these two equations. Let me take them. The best part of this, we don't have to write it again and again. Okay, mg sin theta minus f is equal to ma and r is equal to mg cos theta. Okay, I know that force of friction is mu r, and mu is, let it be mu only. It will be a certain value given in the question, but the value of r is mg cos theta, which I can certainly put it over here. So the value of value of f frictional force is mu mg cos theta, which is ready to be substituted over here. Is that clear?
Yes, sir.
Now, after substitution, I will get mg sine theta minus mu mg cos theta is equal to ma. What do I need from here? I need the value of acceleration. So can you see m is there in all the terms?
Yeah.
I can divide both the sides by m. So that will give me g sine theta minus mu g cos theta is equal to a. If you want to write in a more simplified form, you can also write like this: g sine theta minus mu cos theta is equal to a. That's the final answer. Okay, now in actual question, there will be values of theta and mu given, so you can plug in and get the proper answer.
So once I will write this down.
Yeah. You want to write the previous thing also, like it has been started from here. Okay, the equations were started from here, and then we
Yeah.
go on to the next slide. Okay. And always make a habit of drawing these diagrams in the question. So like it will be easy for you to interpret what is it.
Yeah. Okay. We can go to the next slide. Okay, thank you. Yes, it does.
Okay. Now next we are going to discuss one case of tension. Okay, tension in the wire. So whenever we are talking about strings or any rope, the force acting on the string is called as tension. Okay, so let's say if this is some fixed end, on that there is a block of mass m which is suspended. Okay, so if I want to draw the free body diagram for this, okay, how will I draw it? So you have to imagine that you are cutting the string over here. Okay, you are cutting the string over here. When you will cut the string like this, so mm, it will be like this. Okay, this is separate and this is separate. I hope you understood what I have done. I've just cut the string from there. Okay, so whenever we are cutting the string from any point, Newton's third law comes into action and it will always create equal and opposite action reaction pair of tension.
Okay.
Okay, is this thing clear?
Yeah, sort of.
Logically, tension at every point on the string is equal and opposite. It means it is same, na? That's why we can say there is zero tension on the string. Why we
Yeah.
say zero? Because it is equal and opposite. Okay. So saying zero is bit vague because it doesn't mean that there's no force acting on the string. Okay, like in chemistry, we say equations are in equilibrium. So equilibrium,
Yeah.
it is not visible from the naked eye that there is any reaction happening. But does that mean that any reaction is not happening?
No.
Reactions are happening, but why we are
Yeah.
calling them an equilibrium? Because the rate of conversion of reactant to product is same as product to reactant.
Yeah.
So visibly there are no changes possible, like there are not no changes visible, but still they are happening. So the same thing is happening over here. Okay, tension equal and opposite. Always we have to do like this in order to make the free body diagram. Okay, now there is one more force which acts downwards, that is mg. Okay, so over here if I want to write the equation, it will be T is equal to mg. Okay, and if you see this part of the, like, if I just take this part, right now I have written that this T is equal to mg. So it means that the tension acting at this part, na, that is also equal to mg only. And that is
Yeah,
very
because
logical because the weight of the block is actually putting tension on the whole string. Is that clear?
yeah.
Okay. Next example which we will be taking is, let's say you want to put a photo frame. Okay. And the photo frame needs to be put like this. This is a photo frame. Okay. And you are using two strings. I'm assuming that the whole system is equal, like it is uniform on both the sides. Okay, it is symmetric. So you have to draw the free body diagram for this. Can you try? The mass of the photo frame is m. Okay, it has been hanged by two strings like this. Okay, so you need to make a free body diagram and just make a rough free body diagram. And do you have your phone right now?
No, sir, my mom takes it where I have classes.
Okay,
Yeah.
then you can show it
Um,
to me on camera. Okay, I want to see how you are drawing that.
so Sir, over here the forces of tension and the force of of tension and weight would be equal. Yeah, because T equals to mg.
No, that T is equal to mg was applicable for this system. As soon as the system changes, everything will be different.
Sir, I'm not sure. I thought like the forces would be balanced.
It will be balanced, but how we are going to draw it? Okay, anything you have tried so far, or you are just thinking?
I'm still thinking.
Okay, I'll do it. I'll give you another
Okay.
chance for another question. Okay, all you have to think, try to generate the same thought process. Okay, we need to imagine that we will cut the string from here. Okay, now if the string is cut from here, what part of this diagram we are going to analyze? Only this much? Can I say that?
Yeah.
Because we are cutting it from
This
both.
much. Yeah.
Yes, okay. Now, whenever you are cutting the string, the tension is equal and opposite. Now, since it is like a balanced photo frame, it is not tilted on one side, it is not misbalanced. Okay, it is properly balanced. It means that both the strings will have same force. It will have same tension. Can you think like that?
So both the
Both
yeah.
the strings, both of these ropes or threads,
The same
whatever you are using,
tension.
they will have same tension because it is exactly hanging in the middle in a balanced.
Yeah.
Okay. And the mass will exert only one force mg downwards.
Yeah.
Okay. So this is
Also,
what the
we draw both the ropes as
yes,
two forces.
yes,
With,
yes.
oh, okay. I don't know that. Okay. Okay.
Okay. And now
Yeah.
to the like if you want to solve the question, okay, how you're going to solve. So for that there will be some more information given in the question. Okay. They will give like this that these angles are theta. This is theta, this is also theta. It is exactly symmetrical on both the ends. Okay. So I can draw the same thetas in free body diagram as well. Okay.
Yeah.
Now what will be the component of t in the direction of theta?
Uh, so it'll be t cos theta in the direction of theta. Yeah.
Yeah, yeah. It is correct. It will be t cos theta. So this will be t cos theta.
Yeah.
This will be t sin theta.
Sin theta.
Okay. Similarly for the other one also, this will be t cos theta. And this will be t sin theta.
Yeah.
You can see that it is all about playing with the diagram. I'm just playing with the diagram, nothing else. Okay. But I am clear in my head that what I have to do. So that clarity will come with time. You need not hurry to bring it today only, now only. Okay. But try to understand whatever you can from here. Okay. I'm sticking to only one concept from where I started today's lecture, that components are always in the direction of theta. Like cos theta will always in the direction of theta. Okay. Now you tell me that the net vertical forces, what all vertical forces you can see in the system.
T cos theta and mg. But like two of t cos theta.
Correct. We can see 2t cos theta. So vertically upward it is 2t cos theta and downward it is only mg, assuming that the system is at rest. So 2t cos theta is equal to mg. That will be my first equation. Clear?
Yes, sir.
And the second equation I will not get from here because I can observe that t sine theta and t sine theta are literally cancelling each other. Can you see?
Yeah.
They are equal and opposite. And because of
Yeah.
this only, my photo frame is not tilting in any of the horizontal direction.
Yeah.
Okay, think of a practical scenario that photo frame is very still at one place. Why it is still? Because on both the sides, the forces are t sine theta. They are same.
Yeah.
Okay, now if you just pull the row from one side, then what will happen? It will tilt because you're changing the angle from one side. So if you change the angle, this t sine theta will not be same. Because of that, the frame will be tilted on one side because the net force on one side is more. Are you understanding?
Yes, sir.
Okay, so that is the only conclusive statement we can get from this particular example. Clear?
Yes, sir.
Anything you want to draw from here?
No, this is being recorded, right?
Yeah, it is recorded. It is
Okay, yeah.
recorded.
Yeah. Yeah. Okay.
Okay. Next and the last case which we can see, uh, a mass pulley system. Okay. Now in this mass pulley system also you can see that on both the sides the masses are same. Okay. Since the masses are same and this string is going across the pulley on both the sides. So whenever we have such a case, the tension in both the strings will be same. T.
Okay.
T. These tensions I'm just putting in the upward direction, but usually if you imagine that you are cutting the string, then it will be equal and opposite. You don't have to make the other one. Okay. The weights mg will be acting downwards. Assuming that the whole system is at rest, we can just write T is equal to mg from here also. It is very easy. Okay. If the system moves in any of the direction, then accordingly we'll write net force is equal to mass into acceleration. From that part, we will be continuing in the next lecture.
Okay, sir.
Okay. Now next
Yeah.
lecture is due on Friday.
Okay.
Friday, most probably the timing will be like this only, around this only. Okay.
Yeah, sir.
Okay.
Yeah.
We'll be continuing
Okay.
same. There will be few more cases and possibly it will become more clear. Okay. But still you try
Yes,
to
sir.
revise everything before Friday.